Okay, so in last class we discussed about what?
The power is
9.7. Let's take a few more questions, then we start the last section 9.8, which is basically the series. Two series, scalars and logarithms. There are two series. So let's start first this 9.7. We take two, three more questions. Then we go for this series. Yeah. Nine point seven, and we have power series. Okay, let's take this 16 question, please. Sigma 0 infinity. Question 16. Sigma n is 0 to infinity.
-1
Power n.
times x power n plus 1
Okay.
over square root of n plus 3.
Like that?
Yes.
Okay, so part A, we have to find the interval of convergence. Okay? So first we need interval of convergence. Interval of convergence means we need capital I. So what we discussed in the last, we have to apply ratio test or root test. So I think it's better if we can apply here root test. So because there is no factorial here, so let's take a look, please. So if you apply root test here, limit n approaches to infinity. And okay, please, if you don't mind, can I apply everywhere? Huh? It's okay? So basically, I am applying everywhere n because I have numerator and I have denominator. So basically, I apply the nth root of numerator and denominator. In the numerator, I have product, so I can put them separately.
We have like a -1 x to the power n. When we add,
Yes,
yeah,
here.
when we multiply, it's
Exactly.
cancelled.
Yes, you're right. You're right. Exactly. -1 power n, and then I calculate the nth root. Yes, you're right. And it has absolute value as well. Okay. Okay. So now, yes, you're right. This is cancelled out, And then in here, if you distribute n by n become 1 and plus 1 over n, and definitely the denominator. Okay, so okay, minus 1 in absolute value, no need for that. It is become positive. You can reject it. Okay? This x has 1 plus 1 by n. Okay. And here in the denominator n plus 3 over 1 by n, it has no absolute value. Right, okay, now please, if you apply here, limits, so 1 over infinity, 0. So you have now here x power 1. Do you have right? Okay, what do you think about this denominator? See, means if you, I think I shared with you
Yes.
two forms, n raised to power 1 by n, or even
N
if you have something n plus 1, and raised to power 1 by n. This is what?
One.
Exactly, this is 1. And even you can check, you have the calculator, you can check this. Okay, so yes, you're right. So this denominator will become 1. 1 by infinity is 0, so 1 plus 0 is x power 1. So basically, I'm asking, when we apply the limits here, what you get basically after all?
One. And the absolute value of x.
Very good. We get absolute value of x because 1 by infinity is 0. So 1 plus 0 is x power 1. Clear? Understand?
So isn't it root n to the power 1 over?
No, this is a complete. Denominator, you cannot, denominator has addition. So you cannot put 1 by 1 power. No. If it's product, like up. Oh, yes, you can distribute. Yes. Okay?
So now we put the rule of adding n inside, then it's going outside of one.
Yeah, this property I shared you put answer. Means n raised to power 1 over n and limit n approaches to infinity.
So
Or n plus some constant here with.
So even if the n has a root,
Oh, yes.
1 plus 3.
Basically, it's 1.
so even if the
1
n,
plus 3.
Huh?
On the denominator, we put 1 plus 3.
1 plus 0. No, with any constant, I could see any constant, please.
We accept under power.
Yeah, it's under power of 1 by n.
Like this.
Because this is the denominator, please. So take the nth root on the complete denominator.
So the n doesn't have to be the power, right?
Yeah, exactly. Yes, exactly. Means actually the thing is that here any power here it doesn't matter, right? And any constant here adding, no problem.
Because there was square root.
You can check even from the calculator piece that if you take a very big value here, let's say 10 power 5, it has square root plus 3, and take the 1 by 10 power 5, check the output, it is 1. Okay? Understand? Okay, so what's the answer here?
Absolute value.
Is it first case or second case or third case?
That
It's the third case because first case if 0, we know the fixed roots of I and R. If infinity, we know the fixed roots of I and R. It's third case, it's not 0, it's not infinity. So please let me know what I discussed in last class. If it is not first, second case, so how we go for third case? Yes, because the part A required interval of convergence. So root test or ratio test, they converge if their answer is how much? Less than 1. And this is which inequality? Absolute value. How to answer? Less than 1 and greater than? This is your answer. First part. That's it.
Now we should test on the.
Now, part B, radius. Radius of convergence.
Radius equals 1.
So part B, sorry. Now part B, we need capital R, radius of convergence, please. Radius of convergence.
2.
Radius of convergence.
So
Means
it's circle.
capital R, 1 minus 1 divided by 2.
1.
So it is 1. So half of the length of I, okay? The half length of I is basically radius convergence. Okay, so this is true.
The interval is in part one, part three.
Yeah, part A is interval, part B is radius convergence, and now part C, we have to check on which values of X the series converges conditionally. And in the last class, I explained the rule. What does it mean by how to check conditionally converge?
Absolute value.
First, we calculate with absolute value, and then we check without absolute. But please, with absolute value, the answer must be diverges. And then without absolute value, the answer must be converge. Then we say on this X value, the series converges conditionally. Okay, which values basically we check? Boundary point, because you know very well. This interval shows you between minus and 1 on each X value series converges. We only have doubt on the boundary point because we don't have equal sign here. So first we check minus, right? So first of all, please, now C part we are going to answer now, please. Part C, what we have to check conditionally converges. Conditionally converges. This is basically our topic now, part C. Okay, so what's the first point to check?
Negative one.
So when X is equal to -1, where is substitute this point?
And the X is that.
In the question, in the X, right? So go back to question, please. If you look at the question, it is basically sigma n is equal to 0 infinity -1 raised to power n times what? X?
Yes.
X power n?
X power n and then X.
X how much?
Negative one.
-1. The power how much?
N.
And divide by a root of
Plus one.
That's one. Then it's X to the power n plus one.
n plus 1. Okay, thank you very much. And here n
Plus three.
plus 3. Okay, the first time we go with
Absolutely value.
absolute value. Okay, first of all, we go with absolute value. Okay. Now, now we have to, simplify our series so that we can decide this series, which type of series, and this is converges or diverges, please. Okay, so now sigma n is 0 to infinity. This is -1. Okay, so it becomes n plus 1. So -1 raised to power how much? 1 plus 1? Yes or no?
Yes. We combine them because they're both -1.
Yeah, because the bases are same, so you can combine them, it's fine.
And
And
then
divide by square root of n plus 3, and they have what? Absolute value. Okay. By the way, when you substitute here 0, okay, you know 2n plus 1 is which number? 2n plus 1, basically output is what? Odd. Odd, okay? So whenever you substitute any n value, 0, 1, 2, 3, 4, 5, -1 will get odd power. Okay? And we know very well, -1 odd power is always negative, but what you have outside? Absolute. So it means the numerator is always positive. So you can write that because of this absolute value, my numerator is always what?
one.
1. Now divide by, okay, come on here.
And
0 to infinity. This is root and answer how much? Positive. What is next number?
three.
So plus 3. So the denominator also positive. So basically you have square root and plus 3.
Now we should use
Huh?
SSD.
Now it's your choice. Okay, now look at this, please. After evaluating from, please, you need the concept of the series, please. -1, basically, if it is in the absolute value, its answer always positive, okay? Then square root of n is always positive because it is 0 to infinity, it's positive sign. Plus 3 also positive. So basically, no need to find put this absolute value, okay? So numerator always give you a positive answer because of the absolute value. And here is no need for absolute value because root n plus is already positive. No need for that. Okay. Now, how to check this series converge or diverge? Now you have to go back and check which rule will help you. Yes, please. Yeah, basically we have two options, DCT or LCT.
This is for sign, right?
No, no.
And you could use percentage, it's better.
For example, if you want to use here DCT, it's fine. But in DCT, you have to take big small. Yes or no? Okay. So please, what you say? I told you LCT is much stronger. Okay, but it needs calculation. What are the LCT calculation? AN divided by BN, and you have to find the limit on infinity. If the answer is a positive finite number, whatever decide is the answer. Okay, so let's say we go for LCT, it's fine. So please, I'm using LCT. Let's say this is my A sub N, my question, okay? Generate B sub N. Yes, what is B sub N?
1 over square root of 1.
Okay, decide this is which series and what?
PC.
P series and
This is 1 type by 2.
divergence. Okay, this is P series and divergence. Okay, now if you are okay, can you use the DCT? Just check who is big, who is small. I think no, this is not what I think. Okay, don't waste time. Go LCD, please. So what LCD says?
A
Limit.
over 3, limit 1 and approach
And
infinity.
infinity A sub N divide B sub N. Am I right?
Yes.
Okay, so please, what is the you can say up degree and actually not degree, but anyway, you can change into sorry. Yeah, it's okay. It means n half power and here half power. So
1 over 1, so 1.
so what is that?
1
So basically, as per LCT, it is what?
1. Once an FCT, whenever.
See, this is infinity or infinity case. So don't worry. Take the up derivative and take down derivative. 3 is constant. It is 0. So they cancel out. What's the answer? Okay. So if what LCT says, if calculation answer is positive for finite number, whatever you decide, this is the answer. So what do you decide? So this is what? Yes, please keep absolute value. What's the answer? Divergence. I hope you understand. With absolute value, what is that? Divergence, okay? Actually, this numerator you can solve in other way, but because of the absolute value, I did not spend much time. Because now we go without absolute value, so you will see how we play with this 2n plus 1. Anyway, yes, please.
How from -1 to n plus 1 we got 1?
Yeah, the thing is that basically. Okay, I think it's better. I can use that thing which I will use now next. This is -1 raised to power 2n plus 1. Okay. Can I break this one like that? Can I break this 2n plus 1 like that? Yes or no? Any number with power 2n, you know what's the meaning of 2n? 2n is even. Any negative number with even power, is always what? Positive. This is -1.
Absolute.
With absolute value, what's the answer?
1.
1. Actually, right now, basically, I will use this concept without absolute value. Okay, I did not discuss this one here. Why? Because absolute value is always positive, so no need to spend much time. Now, the same. Yeah, this one.
Can you repeat the last step?
This one?
Oh, we got one. Yes.
Actually, now use LCT.
Yes.
Limit comparison test.
Yes.
AN divided by BN.
Yes. We flip.
We believe now this is infinity or infinity case. We use nominal rule. Derivative of numerator and derivative of denominator.
Why didn't we take the degree?
Okay, you can use no problem. Okay,
like one over.
It's half power, done half power, okay, take coefficient, it's fine. It's okay, it's okay. Although it's not allowed because it's not polynomial, but it's okay. It's, to some extent it works. Okay, it's fine. If you understand like that, it's okay, good, no problem. Okay. Same thing without absolute value, please. Okay, please. As I told you, when you go without absolute value, don't make any calculation. Just from here, remove, please. Just remove the absolute value. Now, please, I'm writing now. Now, without absolute value. Without absolute value. Okay, so please remove the absolute value, please. Sigma n is equals to infinity
Negative.
minus 1. Can I break like that, which I did before, please? And divide by square root and plus. Okay, right. Now, without absolute value, okay? Without absolute value. Now look at here, please. Answer has power what?
2n.
2n. The answer of this part is always positive, without any doubt, because its power is even. Understand? Okay. So now, I have, yeah, in the numerator, I have what? -1. Understand? Divide by square root of n plus 3. Do one thing, this negative sign, just keep outside, please, here. And put this in here. Means I put the negative outside and 0 infinity. And look at here, it's the same thing you get before. You have to check with, you have to check this series by what? LCD. And we know already the result. This series is basically this one. Yes or no? And what's the answer? Diagonal. So without absolute, also what? Diagonal. So is condition virtue?
No.
Yeah, please.
I just have a question. Now, if it's the same steps, there's no need to repeat.
Yeah.
We just try that.
I did same thing. I did it. I did it. As I get this thing, which I checked already,
Yeah.
so I decide. So don't waste time because it's same thing you are getting again. Please.
The negative sign doesn't have any.
No problem. Because if it is diverges, so what the next time will be the whole. Maximum it say negative infinity, again diverges, don't worry. Clear? What is the next point to check? 1. Okay, good. So now when x is 1, please. When now x is 1. When x is 1. Okay, so sigma n is equal to infinity. What's that? Minus 1 power n and x power n 1. X is 1. So 1 power n is 1. Divide by square root of n plus 1. And it has, sorry, 3, not 1, 3. The question 3. 3, okay. Right, with absolute value. Now, minus 1 power n with absolute value, answer always x n plus 1. So anyway, 1 with power n plus 1 doesn't matter. Okay, so it doesn't matter. So now, because of this absolute value in the, numerator, minus 1 power n answer always positive. For 1, yeah. So, and the denominator is already positive, so it don't require the absolute value. See, if the denominator means if something is required absolute value, you cannot remove it. Here we are removing absolute value because it isn't required. 3 is positive, is not required absolute value. Root n is positive, it doesn't require. So that's why we are removing, okay? So now here, 1 over a root of n plus 3 sigma. Oh yes, it is same thing we have been last already. Am I right? Yes or no?
Yes.
So this is what we decided already. This is divergence. By LCT, we have done already calculation. It is what? Divergence. Okay. Now, so this is with absolute. Now same with when x is 1 without absolute. Now please look at here. I'm writing down just for your reference. Now without absolute. without absolute, please, without absolute. Okay. Just remove the absolute, please. So n is 0 infinity. I have minus 1 power n. Then 1 power n plus is 1. No need for that. Divide by square and n plus 3. Okay. Can I remove minus 1 power n because it is always positive?
Yeah.
Huh? No, there's no absolute value. Before it was absolute value. So the output of this part with absolute value is always positive. So no, so it's always 1. We know. This time we have absolute value? No. Now check which is test you use now.
LSC.
AST, alternating series. These are now alternating series because we have minus 1 power n. Do you know? If you have sign controller who has two forms, minus 1 power n or minus 1 power n plus 1, this series is called alternating series. And we have a test which is called alternating series test 9.6, which we understand.
There's two cases.
Good. Sorry?
There's two cases.
Yeah, two conditions we have to check. Yes, very good. Okay, so please. Just for your reference, I'm writing here that we are using alternating series test to confirm about this series converge or diverge. Understand? Okay, so please start. Number 1. The first condition is that the answer of this sequence should be 0 if you say 1. Please, I told you, in ASD,
We don't take the next.
sign controller, we do not consider this in calculation. So I have 1 over root n plus 3. Apply here limit. What answer? First condition true.
Yes, not the.
Now check decreasing. Here in this 9.7 question, I told a shortcut for decreasing.
We can specify directly.
I told you if next value is less than previous, it is decreasing. Please check.
That's decreasing.
Decreasing. So second is also decreasing.
But if you show us again how you do the shortcut.
Sorry.
It's adding to 1 over square root.
Put here 0 in the question.
1 over square root.
Yeah,
of 0
exactly.
plus 3.
Means yeah, put here, okay? So 1 by 3. Next put here 1. It becomes 1 by 4.
You start from the domain.
Yeah, of course. Exactly. 0 to infinity. Put 3, 4, 5, check the answer. If next is less than previous,
It's decreasing.
it is decreasing. Actually, we call like that. N plus 1 is less equal to n. I mean, if next value is less than previous, so it is what? Decreasing. Both conditions justify. So this series without absolute is what? Converges. Now look at here, please. Now it is converging. Okay, this is convergence. Now when x is 1, when we use x1 with absolute value, what is that? Diverge. And without absolute value, converge. What does it mean? At 1. This question number 16. This power series is basically converges conditionally at which point?
1.
At 1. So please write here
Open bracket negative 1.
that series converges conditionally. Converges conditionally. Conditionally at x is equal to positive 1. So what change will come?
You just close the bracket.
Now we go back in part A where you have capital I in terms of convergence here. This is basically open. Which part will make use?
1.
Yes. Means right. Minus 1 open and positive 1 closed. Hope you understand.
So even if it's not absolute convergence, only
Conditional.
even conditional, we close the.
Yes, exactly. You're right. You're right. All right. Because if it is absolutely convergence, then there is no condition. Okay.
We still put only on constant one, right?
Yeah, it was only part 1 is conditional convergence. Minus 1, both are coming diverge. So minus 1 not make your close, please. Yes, please.
So we only close it when we know it's convergence.
Yeah, means exactly. Means if look at here, when we put minus 1 with absolute value, it is diverges, and without absolute value, also what? Diverges. That's why minus 1 there is no conditional converge. So minus 1 remains open.
What if you have the
Condition. So to go and close it.
Oh,
Yeah, of course.
Like if we have the with absolute value converges.
No, with absolute value diverge. With absolute value diverge and without absolute converge. This is
the
called
condition. Yeah, condition.
with absolute value diverge and without absolute value converge. Like it, get it.
Yes,
With absolute value was answer.
Okay.
Diverge. And without absolute value,
Converge.
then it is.
That's why you cross.
That's why we say yes.
Section 1.
Yeah.
The first step in the SCP.
Yeah.
Which is here. Can you repeat it?
Actually, take the
The
sequence.
first case.
Yeah. Sequence. Apply limits. 1 by infinity part.
4 by infinity.
0.
Yeah.
Yeah, that's fine.
Oh.
Okay. Understand? Let's take one last question, please, from this topic, because I think I make it clear. Yes, please, sorry.
Checks for x equal 1. We can like consider the negative sign outside 1.
Oh, no, there is not coming outside 1. When you put 1, now x is 1, not minus 1. When x is 1, please. So x here is 1. So 1 power n plus 1.
Negative.
This one?
No. It's this one.
This one?
Yes.
I put it outside.
Okay.
It's a constant. So this series which we have done here, this series 1 by root n plus 1 is basically diverged. Diverged by infinity. Infinity has negative sign. This is diverged. No effect. That's it is negative infinity. In this case also is diverged. Understand? Negative sign mixed but with infinity.
Yes.
Okay, so infinity times anything means negative sign only change the sign of infinity, but it don't make the convergent. Because at the end, the answer is infinity. Is either positive infinity or negative infinity, but it's still diverge. Clear? Okay. Right. Now please try yourself. I give one more question, please. Question where we have to make some square. I think 13. Yeah, okay. Okay, please try 13. Just try 13, please. 13, please. 4 power n x power 2 and divide by n. Do you have you have the book with you now? Open book?
Yes.
Can you take some question? Please, I want to check. Because I want to show one. The thing which I need to discuss with you, you answered me already. You answered me already, by the way.
These are the accessory.
Yeah. Yeah, there's one question here, it is 43. Yeah, but it has because in 30 it's only x. X we have done already. I want with x some value that here, x minus 1. Yeah, please. I think this question can go. At least I can give some another idea. So it is 43 question, please.
Yes.
Yes, sigma
0 to infinity.
n is equal to 0 infinity. Yeah,
And then x minus
x minus 1.
2 and
2n because here I have 2n, but it is only x.
Okay.
So I want that some number will come with the x so that when you apply the absolute value inequality, you get some answer. Divide by
4 power n.
4 power n. Please try this question, please. This one. It's okay. Both are same. 13 and 40 same concept that they have a square, with n they have power 2. Anyway, but it's only x. So you get only absolute value of x. That's why I want it should be like that, something number here, so that you can practice, okay? Anyway, please go ahead. 43 question, please apply here. Which steps you'd like to apply here in 43? Which test? Root. I think it's better root. In a small time, short time, you can get the answer, okay? Ratio test takes length. You can apply ratio test, but I recommend you use ratio test when you have factorials. Okay? Please apply here the root test and give me the output. What I'm getting output. What is with absolute value? What you're getting?
X minus 1 squared over 16.
X minus 1 square absolute value, okay? Don't forget absolute value. Don't forget absolute value, please. So we're talking about now 43 question, please. Question 43. Sigma n is equal to 0 infinity x minus 1 raised to power 12 and divide by 4 power n. You apply here ratio test limit and approaches to infinity. So x minus 1 power 2 because divide by n and then cancel. Divide by n and then cancel. Am I right, please? Good. Okay. Limit is on what? N. Do you have n here? So this is, you can take, means this is the answer, that's it. When you apply limits, no effect. So basically you get now x minus 1 square absolute value divided by 4.
It's not responsible.
Yeah, actually this is the thing which I want to show you.
But
Here, now please,
X minus 1.
x minus 1, okay, please, for the sake of part A, we need interval of convergence, please. For part A, we need capital I. We need this capital I, please, okay, interval of convergence. We know very well for convergence, the answer should be what?
Less than.
Less than 1. So, x minus 1 square absolute value divided by 4 should be what? Less than?
Can we move
1.
on?
Just wait, we can. Now, next, please. Simplify. 4 and 4 here. So, x minus 1 square absolute value less than how much? 4. Okay. Understand? I'm just simplifying. I remove the 4 from both sides. Mean this and this cancel out. This is gone. So okay. Now yes. Now here basically no need for absolute value. Why? Because square is positive, so it doesn't require absolute value. Now this is basically which inequality and how you solve it. Yes, this is quadratic inequality. How you solve it?
That's where we would have this.
No, you cannot classify it, please.
We have one this time, no.
Basically, you know how to solve quadratic inequality, please? X minus 1 square minus 4 less than 0.
What about negative?
Now, basically, this is quadratic inequality. You cannot apply square root because inequality not equal sign, so you can get the answer. Do you know how to solve the quadratic inequality? How to solve them? What are the methods to solving quadratic inequality? No? In algebra, you already discussed, I'm sure.
What's the like?
No, actually, it's not linear. If it's degree 1, okay, you can move and you can remove, it's fine. It's degree 2, basically. So it's quadratic, yeah, please.
The square, then you
Then,
find x.
okay, after that, yeah, actually here, there are 2 methods to solve quadratic inequality. One is called algebraic procedure, means through calculation. There we need a table. The second method is called graphical method. So graph method is much easier. Table will take time. Do you know what is a square function graph? Parabola. Yes, good. And this parabola is concave up or down?
Facing down.
Up, face up. Because x square coefficient, when you open it, it is positive. Yeah. So use the, please, object means basically we need to solve. As we get the solve, we get the capital I. X value, we need x values. So use here the graphical method, which is basically called, we have to draw parabola. So look at here, parabola concave up or down? Very good, up, okay. Here I need x values, please. I need this x values, this and that, please. So, Uh,
1, 3. Take the roots. 1.
object now.
Zeros.
Oh, good. Okay. Yes, please. Give me the zeros. Open it and then please simplify it and give me x value. So that 3, 3 and -1. Okay. So please, do you know what I draw? This is what? This is x-axis. This is x-axis, please. Okay. Don't confuse. This is x-axis. I draw the graph. Let me give you again, please. Please, I am using graphical method to solve quadratic inequality. What's the procedure? Draw the x-axis. Draw the graph of parabola. Parabola concave up as per our calculation because x, when you open it, x is positive, please. So concave graph, please. I need the x-intercepts. Mean give me the x values basically. X values. So you told me -1 and 3. Very good. Okay, look at this one. This quadratic expression should be what? Less than 0 means what? Less than 0 means what? Negative. Your parabola is negative from where to where?
From negative.
0 to -1.
From where to where negative?
1 to 3.
This is negative side. Yes, -1 to 3 because below the x-axis. So this comes. My x-axis basically greater than -1 and less than 3. That's it. So as you solve quadratic inequality, oh, you get the answer basically. See, this is now quadratic inequality. Okay. There are two methods to solve quadratic inequality. If you go back, you can search on YouTube. You can find. One is called algebraic method.
I mean, like why we took the down part.
Because less than 0, less than 0.
Yeah.
Less 0 means negative. So this is x-axis. How do you know my graph is where positive, where negative? Above the x-axis graph positive, below the x-axis graph negative. We need negative graph. The negative graph is from where to where? -1 to 3. So this is my answer. So this is part A. This is my capital I, please. This is our capital I. I, which you can take it like that, -1 and 3. Understand? Yes or no? Now we need R, part B. Part B, please. Capital R. Radius of convergence, please. R. How much? 3 minus -1 divided by 2. I think it's 2. Yes or no?
Yes.
Yes. Okay. Now part C. Conditionally converge. So which 2 points we have to check?
-1.
-1 and 3. Okay. Start now, please. So I have now part C, please. Conditionally converge, please. So now when x is equal to -1, okay. So please put in the question -1x. So it is equal to 0 infinity. What's the question?
What? Yeah. X
X -1. Now one half x how much?
Negative.
-1 power 2 and divide by 4 power and first time with absolute value. I first of all I put in my question x -1, please. I want to check which series I will get, okay? And you know very well, first we check with absolute value. Okay.
Actually, we always check with the -1, positive 1.
No, whatever you get answers in the interval. These are the interval answers. Boundary point, this point, boundary point are -1 and 3.
Then we check negative 3 and 3.
First check -1, then we check 3, okay?
One with the absolute value.
Yes, for example, with -1, first we check with absolute and then we check without absolute.
Only negative 1.
Yeah,
Yeah.
then take 3. So with absolute and without absolute,
Yes.
okay? Okay, -1 is how much? -2, it has power 2 and divide by 4 power n, it has absolute value.
Equals.
Infinity. Okay. Right. I think you can see here, this negative, it has power how much? 2 power. Okay. If it is 1, then we can say exactly,
Can you make four?
we can ignore it, but right now we cannot ignore it, please. So it becomes 4 raised to power n. Yes or no?
Yes.
And here you have -1. -1 power n. Okay, I will make more clear, please.
How we separate the powers?
Yes, look at here. Yeah, means actually we make the 4, so no need for that. Anyway, look at here. -2, I can write -1 and times 2. Agreed? Can I write -2 like that?
Yes.
Yes or no? Okay. 4 power n and absolute value. Okay, now next please. -1 has power, okay, -1 has power 2n. 2 has also power 2n. Look at here. I have two points, two terms which are product. Both have 2n power. I make separate. Yes or no? Can I write? -1 is under power 2n. 2 is under power 2n. Agreed or no? Divide by 4 power n. 4 power with absolute. Well, okay. Now, -1 power 2n, because it is even power, this is always, so this is gone. No need for that. This is gone. Now, please tell me, 2 and power 2n. Can I write this 2 power 2n like that? Look at it. Yes or no? Means 2 power 2 and
Yes.
so what is that? 4 power n. So 4 power n over 4 power n in the absolute value. This is sigma n is equal to 0 infinity. They cancel out. What's the in absolute value? 1. So in the absolute value you have now sigma n is equal to infinity. Now absolute value 1 how much?
Divergence.
Now remember, if a sigma has constant, what's the answer?
Divergence.
Yeah, I'm reading and it's divergence. So with absolute value, it is what? Divergence. Now, without absolute value, actually, do not do anything. Just remove from here without absolute value. If you remove here absolute value,
Also.
any change will come?
No.
No.
So diverge.
So without absolute value, also what?
Diverge.
So with absolute diverge, without absolute value diverge, so conditionally converge?
No.
No, it's not. So at 1, sorry, not 1, -1. So at -1, it is not conditionally converge. Because both behave same. With absolute diverge, without absolute also diverge. Do you understand point? Okay. What is next point to check?
3.
3. Okay. Now, please do calculation with 3. Now, when x is 3,
That's 2.
so the question becomes sigma n is equal to 0 infinity x -1 means 3 minus 1 power 2n divided by 4 power n. First time with absolute value. 3 minus 1 how much?
2.
2 and 2n divided by 4n with absolute value. How much to power 2n?
4. And then the same thing.
4n over 4n with absolute value. 4 and 4n cancel out
1.
with sigma.
Divergence.
If you remove absolute value,
Also divergence.
if you remove absolute value, any change will come? No. So with absolute, without absolute, also diverge. It means in this question, nothing is conditionally converged.
So the both.
So the interval remains open. No change will come in I.
Doctor, the absolute should be diverged.
Absolute should be diverged,
Without
without should be converged, then we say conditionally converged, then you make it closed, one side, that side. Hope you understand. Get the idea? Okay, that's it. This is basically power series conditionally converged. 9.8 now, the last lecture, please. Okay, so now 9.8. Actually, 9.8 is basically, you can say, application. So, to some extent, we can say that 9.8, because 9.8 is also power series, but there are two specific series, Taylor and Lawrence. They are also power series. They are also power series. So now 9.8, please. The last section for today. Exercise number 9.8. It's called Taylor's.
Sir, do we also have 9.9?
No need for it. Taylor's and McLaurin's and McLaurin's series. Taylor's and McLaurin's series. Actually, Taylor's and McLaurin are two scientists, mathematicians who developed, this series. They said that any function can be expressed as an infinite series. You get right? Any mathematical function in the form of an infinite series. So they develop a formula for that. Actually, there is no difference between Taylor and McLaurin's, with only one difference basically. Now note down that Taylor's and McLaurin's says any function f of x, any function, please, transcendental or algebraic, any function can be expressed as an infinite series. How? Please. This one you can say difference is that Taylor series center about a point. Okay. So let's say the point is, for example, a. So f of a plus first derivative at a times x minus a power 1 divided by 1 factorial plus second derivative at point a x minus a power 2 divided by 2 factorial plus third derivative at point a x minus a power 3 divided by 3 factorial plus, and of course it's continuous. It's continue infinite. It's mean infinite derivatives.
We should calculate first, second, third.
Yes. We ask in exam how many derivatives you have to calculate. Okay.
Only one.
Now this is the Taylor series. Okay. Now what is Maclaurin series? I told you both are same. Now Maclaurin series. Maclaurin series. Taylor's, Lawrence, same. Only one difference. Taylor center about a point A, some point A, okay? Maclaurin is center about
Point B.
0. So wherever I put A,
There's 0.
put 0. That's it. Means any function can be expressed in the form of Maclaurin series, which is center about 0. Look at it. F of 0 plus first derivative at 0 times x minus 0. How much x minus 0? X and divide by 1 factorial. Plus second derivative about 0 and x minus 0 is 0, so x squared and divide by 2 factorial plus third derivative about 0 and x power 3 divided by 3 factorial plus, and of course infinitely continue. So you can see that in Maclaurin series there is no value with x because it is always in about 0. But with Taylor series you have, for example, a is 1. A is 1. So you get x minus 1 power 1, x minus 1 power 2, x minus 1 power 3. Okay. However, in Maclaurin's there is no values, only 0. So you only get x power 1, x squared, x cubed, x4, and continue. So this is basically Taylor's and Maclaurin series, and in 9.8 you'll be asked generate Taylor series or Maclaurin series for the given function. We give you a function and we ask you generate Taylor series or Maclaurin series for this function at some point, please. Two questions from here. Yes.
One say one here.
Yes, we can say one Taylor. No, actually, it's not one Taylor, one Maclaurin. Basically, here we have two types of function. Sorry, two types of question. In first question, we will mention the number of derivatives you have to calculate. We ask you find the Taylor series or Maclaurin series of order 4. Order 4 means four derivatives until have 4 derivatives. What's zero?
Like for the derivative.
Which
Oh,
derivative?
Like for example, I got the first derivative of function, a second derivative also a function, the third derivative 0, then the fourth derivative.
So you stop?
But
Yeah,
what
that's-
is the maximum? But you can have 7 or 6.
No, not 7, 6, 4, 5 maximum, not more than that. Okay. And the second question will not ask you the number of derivatives. Infinite derivatives, the second question. So you have two questions. One question with specified number of derivatives, okay? Second question is open.
The example is,
It's only these two questions, okay?
no, I mean, your type.
10, 10. 9 or 10, 9 or 10, not more than. Okay, so
Doctor, did you say that there's a question for small?
yeah, that one, the previous one.
Yeah, so
Part A, I, part B, R, part C, this one.
6 and then what?
How many
6.30, that's 24. So the others, so 8 more questions. 8 more questions. So 9 questions.
Yeah, 9, 10, maximum 9 to 10, exactly. Absolutely right. Okay, so let's start with some questions, please.
Doctor, the numbers above is not like x squared, it's a first, and second.
Huh?
The
Actually, because there are infinite derivatives, so you cannot write, for example, if you want to write 6 derivatives, so how write? 1, 2, 3, 4, 5, 6, 1. So it's better to write in that form, okay? Yeah. So because I don't know what is that, something here you are getting. So to avoid this thing, we use, it's not power. Basically, it's a power of derivative. First derivative, second, third, fourth, fifth, sixth, and infinite.
yes.
Okay, let's say question means how the question looks like in this section. So let me download 9.8 first, please. 9.8. Okay. Now, for example, let's say 34 question, for example. 34 question. We ask you find the. Actually, there's some difference. Try to understand. It's not any ambiguity. If I ask you find the Maclaurin series of this function, so I will not give you the point. Why?
Because the
Because understood Maclaurin series is centered about
0.
0. If I ask you find the Taylor series of this question about A is equal to 0. Okay, so if I say Taylor series, I have to give you a point. If I say Maclaurin series, you don't get any point because Maclaurin series understood it is centered about 0. It doesn't require any point. Okay, so please try to understand.
Doctor, that's the
So
only
if,
difference.
if they give you a point here, which they say find the Taylor series, but actually we know very well because A is 0, so Taylor series becomes Maclaurin. Okay, so there's no difference at all. But it's a technical thing which they using here. Actually, it's not only zero. I can put any point for you. I ask, okay, put, let's say, make the Taylor series of this function at a is equal to, for example, minus one. Is equal to minus one or one, no problem, please. So I think it's better I change the values so that it becomes some interest. Let's say it is 2. Okay. So please find Taylor series of this question of order 4. Which order? 4. So 4 means?
Derivative.
Yes, we need 4 derivatives of this function.
Dr. do you derive 4 times first?
Yes, we have to derive 4 times. You're right.
Doctor, this is Taylor.
Yes. So 34, just a reference, I'm giving 34, but I change the values, please. So 34 question from 9.8. Function I took same. So please find Taylor series. Find Taylor series of order 3. Okay, we can reduce. We have order time. Okay, order 3. Okay, don't have time. Okay, I have to finish it. I have to take 4 derivatives. So 3, please. 3. Okay, so f of x is equal to square root of how much?
X plus 1.
X plus 1. And what is a I told you?
2.
2. Okay. Now, first of all, you should know this Taylor series format. Okay. Right. We know very well. Order 3 means we have to take 3 times derivative of the function. Understand?
Yes.
Okay, please start.
First derivative
First
is
derivative.
1 over 2
So
squared.
this is 1 over 2 square root of x plus 1. Understand?
Yes.
Now, for the sake of second derivative, basically, I have to take this up. It will become minus half. Am I right? Okay. I just rewrite. I did not do anything, please. I derive. Then, because I need second derivative, I rewrite my first derivative in this form so that I can take second derivative easily. Okay. Now, second derivative.
Second derivative, I can take 1 over 2 as a constant.
1 over 2 is a constant. Then I have negative 1 over 2. Then x plus 1 minus half minus 1 minus 3 over 2. Am I right?
Yes.
Yes or no? I have taken now second derivative.
Yeah.
Yes, and then you take it down.
Do one thing, make it please negative 1 by 4. And I have x plus 1 raised to power minus 3 by
You can
okay.
take it down.
Actually, you have to take third derivative.
So
So keep as it is, okay? So understand my second derivative? I'm using chain rule, okay? Now, third derivative, please. Third, please. Third derivative, please. For third derivative, minus 1 by 4, then minus 3 by 2, x plus 1, minus 3 by 2, minus 1, minus 5 by 2. Understand it, no? You should need fourth. Okay, go, fourth time.
Calculus.
So in exam, if they ask you 4, so please go for 4. Now we have 3 by 8 and then take this minus 5 down so that you can easily get their value when you put the point. Also this, please take it down. Minus 1 by and 3 by 2. Okay, so look at it please. We have calculated 4 derivatives of this square root function. Okay, this is first derivative. You can also make it down so that you can easily get the when I put a value here. So this is 1 by 2 x plus 1 power half in square root. Right now, please substitute in all your because we need the derivative first derivative. Look at it, please. As per the look at it, please. As per the Taylor series, as per this Taylor series, my first derivative at a. What is a? 2. So please go to your first derivative. Substitute x with what? 2. So what do you get now? 1 over 2.
Times 2
2
plus
plus
1.
1, 3. It has 3 square roots. Yes or no? Yes or no? My second derivative at 2. Where is my second derivative? Here. Here. So minus 1 by 4. 2 plus 1 is 3. So you have 3. It has power 3 over 2.
But we don't have to simplify.
Actually, you have to. Let me tell you how you can simplify this. So I can put here. Okay, can you give me the 3? 2 plus 1, 3. 3 power of 3 by 2. How much is 3 by 4? Can you tell me something, please? How I got it? And we have times 4 outside this.
Decimal number.
No. Not put decimal this.
27 times 4.
27 times 4. Okay, it's fine. It's fine. You told me here 27, huh? Okay, times 4. Okay. So 27 times 4, how much? 81? No, sorry. 200 something?
100.
100?
8.
Okay, so yes, we got very good. So we got it 1 over 108, right? I don't know. Let's put in the calculator. 2 plus 1, 3. 3 power 3 by 2, how much?
It's a decimal number.
No.
3 over 36.
Okay. How do you get this one?
This
Yeah, this one was an 8.
you didn't
It didn't put the three.
It just said this.
So in this case, you have 4. Look at here, you have 3. I think it's very easy. 3 power 3, 27. 27 has square root. That's it. What is 27 square root? Just make simplify. I think 3 root 3.
Yeah.
Yes or no? So 3 times 4, 12 root 3. This is a simplified form. 12
Okay.
root 3. Yes or no?
Yeah, you had it as 3 without the over 2.
Huh?
You had it as 4 times 3 to the power 3. That's why I gave you.
Right now, look at
Yeah,
here.
yeah, it's 3 over 2.
No, it's okay.
Yeah.
Very good. So first derivative 1 over 2 times square root 3. Second derivative negative 1 by 12 times root 3. Okay, now third derivative is third derivative at 2. Okay, where is my third derivative? Oh, here. Here. Look at it here. Put here. 2 plus 1. 3. 3 power 5 by 2. Please do one thing. First of all, calculate 3 power 5 and make it square root. Then give me the answer. This is the way to simplify. Okay? Don't write less than answer.
9 per root 3.
Sorry, how much?
9 square root of 3.
You entered 8 times? Times 8? Always or?
72
Okay. Now
square root
3 divided by 72 and root 3, right? Is it? Please check. Don't worry. Here. Look at here. 3 divided by 8. Now 2 plus 1 is 3. 3 times 5 and take its square root. And then times 8. So you told me it is right. It is giving 72. Okay, good. That's right. So this is my first derivative at 2, second derivative at 2, third derivative at 2. Understand? So because they asked us order 3, that's why maximum we calculated 3 derivative. Now please put the values in the Taylor series. Now, do you remember Taylor series? What is the first value of Taylor series? F of A. Function answer at A. What is function and what is A? Tell me. Look at here. A is 2 and function is x plus 1. Put here 2. 2 plus 1, 3. So 3 square root. My first value, F of A. Okay?
You get square root of 3 over 6 practically.
No, look at it. F of A. F of 2 basically. F of 2. F of 2 means square root
3.
3. f of 2. Because as per Taylor series, the first value is f of a.
Sir,
Yes, please.
I just want to tell you something. Here I've got in the question, I wrote the first derivative, but without substituting with two. Like I just tried the first.
Okay, have to, because the rule is that first derivative at a,
So I
second
said.
derivative at a. Okay.
Okay.
Now we got all the values. Now we have to list them in the rule. So f of x was the function square root of x plus 1 is equal to f of a How much?
Square root of b.
square root of b plus first derivative at a. How much? First derivative. 1/2 root 3. 1/2 square root 3 times x minus a. How much a? 2 power 1. Divide by 1 factorial. No need to write power 1. No need to write 1 factorial. Okay? If you want, you can write 1 factorial. No worries. Because factorial, 1 factorial is 1. Okay, next. Plus second derivative at a. Second derivative. Second derivative is negative. It's negative. 1/12 root 3. Negative. It's negative, not plus. Negative. Negative. 1/12 root 3 x minus 2 power 2 divided by 2 factorial. Yes or no?
Yes, yes.
Plus third derivative. What is third derivative? Third here. 3 by, okay, I think you can cancel 3 and 72. Yes or no? 3 by 72 root 3. Okay, don't worry, we simplify in the last, don't worry. We simplify the last.
Will be 1/24.
So 3/72 root 3 x minus a power 3 over 3 factorial, and of course, because we need third order, order 3, stop here. It's not infinite. You see, they are asking finite order, order 3. So 3 derivatives equation is required. Okay. So basically, look at here, means this function you have write in terms of infinite series. Take the infinite derivatives, discontinue. So that this is the basically the concept. A Taylor series, Maclaurin series, Taylor and Maclaurin series. You can write any function in form of the series. Now simplify, please. Yeah, please.
The 3/72 will be 1/24.
Yeah, okay. We go now. We go now, please. So this is square root 3. Here, I don't think so any cancellation. So it is x minus 2 divided by 2 square root 3. Next, 2 factorial means 2. 12 times 2, how much? So x minus 2 power 2 divided by 24 and square root 3. Next, please, plus. So 3 factorial, basically, you know how much 3 factorial? 3 factorial is 6. Okay. So this and this cancel out, then you have 72 times 2. So x minus 2 power 3 divided by 144 square root of 3. So yes, this is my Taylor series, please. Power 1. Okay. So this is our Taylor series of this function. Of this function, please. This function, please. So basically, this is your first question in exam. We ask to generate Taylor series or Maclaurin series of order 4, 3, 5, depends on the question. Yes, please.
Doctor, can you repeat how 3 factorial is 6?
3 times 2. Go back. 3, 2, 1. How to open factorial?
You can open the calculator.
Yes. Factorial means go back. So 3 factorial means 3 times 2 times 1. So 3 times 2 times 1 is 6. 3 times 2 6 times 1 is 6. Okay. 4 factorial. 4, 3, 2, 1. So 4 times 3 times 2 times 1. So 4 factorial 24. Okay. Understand? Yes, please.
To voice or no?
No, no need, no need, it's okay. It's fine. We need series, huh? So we got the series.
So,
Yeah, please. Okay, so as I told you, we can give you any function, sine function, we can give you exponential functions, we can give you to, get the derivatives, third derivative, derivative. It depends. Right, so let's take some more questions, please. That. Okay, can you just answer this one, please? Okay, let me check.
So go back to
let's have one.
the.
Let's try 13 question, please. 13. 13, please.
Hello.
Make it about a is equal to 1. I make it now till. Okay, so order 3, for example. Make it order 4.
It's not
Go on. First derivative, second, third. Okay, third, okay, sufficient. Makes 3 derivatives at 1.
same technique.
Yeah, same technique, exactly, same thing.
Taylor William.
A is given, A is 1. So, Taylor, yes. Taylor series. 1 over 1 plus x, and please generate order 3 Taylor series with center at 1. A is equal to 1. So we can give you any function, I told you, okay? We can give any function, natural log function, sine, cosine, exponential. You need derivatives. You know very well the derivative, okay? You know the derivative, how to derive ex, how to derive ln x, how to derive 1 by x. So you have the idea, okay, please. So this is an open question, by the way. We can give you any function to differentiate 3 times, 4 times. I think it's easy. It's 13 question derivatives. What is first derivative? Minus 1 over 1 plus x. Huh?
Yes.
So minus 1 over 1 plus x squared, right?
Yes.
Then second derivative, it becomes positive 1 plus x power 3. Then you have third derivative, which is becomes now minus 6 divided by 1 plus x power 4. Look at here, in 1 second I have derivatives. So it's not any lengthy thing, so you can easily drive. Now, the only thing is that you need derivative at a given point. So what is the point given here? 1. So wherever you have x put 1, for example, first derivative at 1, it will give you minus 1 by 4, right? Yes or no? Put here x1. So 1 plus 1, 2. So 2 power 2, 4. So minus 1 by 4. Now, second derivative at 1. 1 plus 1, 2, 2 power 3, 8. So 1 by 4. Positive 1 by 4. Third derivative at 1, it becomes 16. So minus 3 by 8. Negative 3 by 8. Correct? Yes. So first derivative, second derivative, third derivative at 1. Now just put in the equation. That's it. And that's it. Okay, makes 3. Sorry. So please tell me, do you understand? Yes or no?
Yes.
Okay, good. So this is the first question, basically, where the number of derivative order will be mentioned. Order 3 or order 4, okay? Yeah, you get 3 or 4 orders. Yeah. It's fine. Now, second question we should get. In that question, actually, the order is not mentioned to you. The order is not mentioned to you. Okay, for example, if I make the Taylor series of this 13 question,
Is it?
I'm thinking that can I link this question with my next topic? I'm just thinking about that. Otherwise, I can change the question. We can go separate question for the second topic. Where, okay, in second topic, please. Second
We
topic.
start the second topic.
Yeah, we start now second topic, please.
Why
In second, I think we finished now before, and then we can go break, okay? We can finish in one session, no problem. So we can finish early, okay?
There's the key.
Because the last topic now. As I told you that in the second topic, the number of derivatives not mentioned, order not mentioned, okay? So how to answer that question, please? Let's take this 29 question, which is 1 by x squared, and A is equal to 1. 29, please. 29 question, please.
The second topic.
Yes, the second topic, please.
I think it is the geometric function question was easier instead of numbers. They call it the trigonometric function.
Sine to sine.
Yes.
Yeah, sine to sine, sine to sine.
Yes.
So the question 29, 1 by x squared. So 29 question, please. The function is, okay, write the Taylor series. Write the Taylor series, okay, Taylor series of f of x is equal to 1 by x squared at a is equal to 1. Okay, now look at the question. Is order mentioned? That how much derivative are required?
No.
No. So, huh? How many derivatives do you need? Infinite. Okay. So start please. First derivative, please. It is minus 2 by x cubed, right? Second derivative, please. Second derivative. If I take it up, I get 6 by x power 4. Yes or no? The third derivative. Take it up.
Doctor, did you mention in the?
No.
No, nothing, nothing.
How we
the-
know?
The number of derivatives are not mentioned. Infinite derivative, yes. So how you ask this question, basically, I'm just trying to, explain. Do one thing, initially get 3. Initially get 3, okay? Please check, is correct my calculation, please? Just check, please, make a round. We have cross check? Okay, good. Now we go with how much A value?
1.
1. Okay, so first derivative at 1 is how much? -2, right?
Yes.
Second derivative at 1, how much? 6. Okay. Third derivative at 1, how much?
Negative 1.
-24. Okay, right. So again, please, there is no order mentioned, please. The second question is an open question. Number of derivatives are infinite. So I told you how to ask the question. Initially, just get 3. And then please calculate their values on the given point A, please. We have done. Now, please make the Taylor series, please. The Taylor series of this function, which is basically 1 by x squared. So 1 by x squared is equal to, as per Taylor series, for the first value,
Substitute the
f of a means, so f how much?
1.
1. Very good. Plus
That's better.
first derivative at 1, how much?
Negative.
Negative, it's not plus, basically it is. So first derivative at a times x minus a power 1 divided by 1 by 2. You understand?
Yes. Plus 6.
Plus the second derivative, how much is?
That's
Okay, so second derivative is now 6 times x minus 1 power 2 divide by 2 factorial. Then plus third derivative. It's not plus, it's negative. So negative 24 times x minus 1 power 3 over 3 factorial and plus and please, it is continue. It is continue because it is infinite series, infinite derivative. Understand point?
Yes.
Okay.
So we always take 3.
Now it depends our understanding. Okay, now the question not finished by the way.
Finish, all right.
No, no. Simplify, please. Simplify. 1 minus 2 times x minus 1, understand? Plus 2 factorial is 2. This is 3, yeah. 3 times x minus 1 power 2. Minus 3 factorial is 6 divided by 24 is 4 times x minus 1 power 3 and plus and continue. I simplified, I reached here, understand? Basically because there are infinite derivatives and of course we cannot calculate infinite derivatives. So we have to write the answer in sigma form. Which form? Sigma form. You have to now make the pattern that this pattern is looks like what? So now we have to write the series in sigma form. Sigma n is equal to 0 to infinity. Please, this starting value may be changed because we cross check. Is it working with our question or no? Understand? Okay. In this question, step 1, you have to check, is my series alternating?
Yes, yes.
Yes.
Check this.
Negative, positive, negative, positive.
So confirm your series is alternating. You must have to include sign controller.
Sorry.
What is sign controller?
Negative, positive.
Yeah, so sign controller is basically negative 1 and power. Okay, good. Now, what you can observe that something is repeating in each and every term. X minus 1. Here is power how much? 1. And then
2,
and then
3.
okay. I can write x minus 1 power how much?
And plus 1.
Okay. One more thing you can observe. When here is power 1, what is that? What is that? When here is 2, what is that? Okay, when it is 3, what is that? So whatever you have here, one number is extra here. So it means the multiplier, see, this 1, 2, 3, you represent by n. And the multiplier, if it is 1, it is 2. If it is 2, it is 3. 1 extra. So how write this multiplier?
And plus 1.
N plus 1, yes. N plus 1. Or you can write here n or write here n plus 1 here if you want. But anyway, this is the best, representation. Okay, it's not finished, please. You have to cross check now. Because you verify your formula. This formula you have to repeat now by yourself. Now check its validity. What is my first one with n?
0.
Okay, please, wherever you have n, put 0. So if I put 0 here, it is 1. Here it is 1. And when I put 0 here, my first value how much? Do you have first value 1? Okay, so my starting is correct. Take one more time, please.
2.
No, after n I have 1. Okay. So minus 1 power, look at here. Minus 1 power 1. Negative. Minus 1 power n means negative. Okay. And x minus 1 power 1. So I have x minus 1 power 1 and 1 plus 1, 2. So my second value should be negative 2 times x minus 1, is it?
Yes.
Oh, yes. So it means my form is working well. My form is correct. Because quite possible, sometimes it's not working. So you have to change here. Maybe it worked with 1. Okay? Maybe, sometimes you have to make change. For example, here, let's say you have to write here, for example, here plus 1. So it depends. When you cross check, so you can see the deficiency, then you can make it. But anyway, first time you try and it is working. And you can cross check. So basically, half marks are for this formula, please. So half marks for this calculation and half marks for this sigma notation, please.
So 1 for this.
So let's say if it is 3 marks for the question, 1.5 marks is here. To make this formula, please. So this is the way we have to get the pattern in the series and then combine a sigma form. Hope you understand.
Yes.
Very good.
And if you couldn't find the notation,
Sorry,
you couldn't find the notation.
I'm going to find the
Notation.
means the pattern. No, the question we give to you, of course, it has pattern.
Okay.
Yeah, you're right. There are many questions where pattern is very difficult. But of course, means the pattern which we give you is not which you really struggle. No. Okay, means you can easily identify that what is going on. Then you have slightly make some setting from here. Okay. Right.
دكتور
Yeah, please. Yeah, please. Yeah.
Doctor, I have a question from the homework. I solved the question, but I couldn't simplify it in the last step. So can you explain? Can I give you and explain? Just the last step.
Do one thing, please send me this question in the Teams, please. So after class, I can check this. Okay.
Doctor, I already solved it. I only in the last step. I stuck in the last step. It won't take time. Only 1 minute.
That's weird. Let me finish my topic first, brother. Because then I have deviated from my topic to the question, please. So
Okay.
send me question, inshallah. After class, I will try to answer. Okay.
Okay, Doctor. Thank you.
Yeah. Thank you very much. Okay. Now, actually, I think I lost the question here. We can practice on the same topic.
This is the last question.
That's what I'm saying. Okay, can you try 31 question, please? 31.
Doctor, this is the last topic.
Yes, last topic. That's it. Yeah.
You want it?
It's the last
Please.
question we solved today.
No, one more, please. I want to make practice and get from pattern.
So, doctor, we want to have 2 lectures.
No, break.
No. We just finish before break, please. We will leave the class early.
But the derivative of E axis.
Yeah, exactly. But we have one, that point, please. So kindly, just point 31 question, please. 31 question, and there is no mention order. So take 3 derivatives, put in the equation of the Taylor, okay, and then at the end try to make it sigma. Yes, please.
So, doctor, most of the questions become level than series.
No, actually, there is no difference in Maclaurin and Taylor. Maclaurin's means there is no A zero.
0.
Yeah. So when you write the Maclaurin, you don't write x minus A. You write x power 1, x power that's it.
Yes. Yes.
Come on, please. It's 31 question, please. Try.
If you get this, that's it. What do you do? The key, the power of 1. So that's it.
No, put it as it is. E power 2, E power 3, like that.
There is no.
So take 3, I think 3 there are enough. You can get the pattern. Here the objective is we need pattern, okay? So e power 2, e power 1, e power 2, e power 3. Okay, right now in the series now. Make series now. Okay, good. Now make series, please. Make the series, inner series. Send about 2 because A is 2. You make a series. So f of A is E plus E plus okay, now make the sig. Correct. Now make the pattern. Write the sigma form then.
We don't have a sign control.
Okay, all are positive.
Yes.
Okay, good. It means there is no sign controller. Okay, agreed. Right. Yes, please. Okay, so x minus 2 power n. That's it. In the division, what do you have? Divide by and factor. Okay, now cross check, please. Open your series. Put n first value. You set first value 0 or 1? 0. Okay. Put 0 in the sigma form and check. Are you getting same value? Okay, good. Now check your answer. Cross check your answer, please. So sigma E2. Okay, so anything in the denominator coming up?
It's okay, power like this.
E square and plus in E square. Okay, do one thing. Cross check your value. Is working? When you're putting n1, are you getting same thing?
Yes, that's it.
Yes. Okay. Yes.
One.
No need to put this in outside.
Let's see.
Yeah.
It won't work.
Put n0. Yeah. And put it inside.
And so it will be divided by 0.
0. Oh, good. 0 factorial
Yeah.
is 1.
Yeah.
Don't worry. 0 factorial is 1.
Okay.
Okay. 0 factorial is 1. So don't worry about that you have divided by 0 factorial. 0 factorial is 1. Is a proof result. Okay. Good. You asked me. 0 factorial is 1, please.
What if it was negative? Negative one.
Negative.
There's no negative.
In the factorials.
Yes, sir, it's the same.
So your phone is working.
Yeah.
So it means a2x minus the power n will infect the wrong solution. Same. Okay. Yes, you're right. Basically, the series which you are getting in 31 question, it is sigma n is equal to 0 infinity e squared
X minus 2.
x minus 2 power n over
And
n factorial. Yes. So we have got the pattern.
why
Oh,
do we have
you
one
understand.
factorial?
Sorry.
Because we have one factorial.
Because we have 1 factorial, 2 factorial, 3 factorial in the denominator, please. When you make the series table series, you get divide by 1 factorial, 2 factorial, 3, so n factorial. I hope all of you same answer, right?
Yes.
Very good. Okay, let's take one last question, please. We are working on same thing, huh? If we have generated a series, please. Sorry, what? 15 part. Sine. Oh, sine. Make it 22, please. 22. Just try it. 22, please. X squared divided by x plus 1. And there is no a. So no a means what? 0. This is 0. So you will then get basically Maclaurin's series. Okay. But we need to find pattern if possible. 22. Come on. 22. Take first derivative, second derivative, please. We have to get the pattern.
Derive this.
Yes.
Still deriving.
I think maximum take 3 derivatives.
Quotient.
Because 3 derivatives, you can get the idea. Yes, exactly. So it means if you go for first derivative, this question, first derivative of f1 and 1 prime. So you get 2x, then minus
X squared.
x squared divided by x plus 1
7.
square. Okay.
X equals 2x times x plus 1.
We have 2x and x plus 1, right? Right. U prime b.
And then 2x squared.
Yes, I'm asking if it becomes like that, it becomes too much x complicated. Anyway, and now minus x squared. Okay, so now we have 2x squared plus 2x minus x squared.
Then you cancel.
So it becomes x squared plus 1,
Yes.
becomes x squared.
X squared plus 2. 2.
X squared plus 2x.
Yes, plus 2 plus 0.
And divide by
X
x
plus
plus
1
squared. Okay,
Then again.
I'm thinking
This is a lot.
If no, it's not hard.
Yeah,
Yeah, not even just take the derivatives. I'm thinking that if I put because if it is zero, if A is zero, I'm just thinking about that. If A is zero, so no, I think it's better. It's okay. You need here maybe 4 derivatives. You know why? Because here is zero, A is zero. So when you put here is zero, your first derivative at zero is how much? Zero. So you don't get any information about the pattern. Now try to please second derivative, please. F2.
can we take x plus one squared up and then product full?
No. Okay. But it's fine. Actually, it's better to keep like that so that you can get some pattern. But yes, if you want, you can take it up and use product rule. Anyway, right now 2x plus 2, right? And x plus 1 equal to then minus x squared plus 2x as it is, and then you have 2 times
X plus.
x plus 1, and this is divided by x plus 1 raised to power 4. Yes or no? Okay, good. Here I can take to make simplify, what I can take is one factor.
X plus one, X.
X plus 1, yes. Basically here, you are required some, more attention to simplify. So this one I can take now x plus 1 as a common
Then
factor.
two X plus
I
two.
get here 2x plus 2 times x plus 1. Then I have get minus 2 times. If you don't mind, I can go to x squared minus 4x. Okay? And divide by x plus 1 raised to power 4. Now here, if I open this one, please, this is gone, right? So it is 2x squared plus 2x plus 2x plus 2 minus 2x squared minus 4x, and divide by x plus 1 raised to power 3. Okay, this, yeah, that's why I was telling you, it's not complicated when you make simplification. Now, second derivative is basically coming up to divide by x plus 1 and power 3. We got here. Second derivative. Okay. Now, third derivative now is much easier. Take this up. Take this up. For the third derivative. So for third derivative, please. Okay, so you have done already. So third derivative is negative 6 divided by x plus 1 power 4. Okay, good. Right. I think take the fourth also so that you can get some pattern. Huh? You can get some pattern, please. So fourth derivative, please. If you go for fourth derivative, it becomes positive 24. Am I right? Yes or no? Take it up, negative 4 and 6, positive 24, and divide by x plus 1 raised to power 5. Yes or no? So I calculated basically 4 derivatives. You get 4 derivatives. We don't need 4 derivatives. We need derivatives at the point A. So in this question, sorry, where's the question? I don't know. Here is basically Maclaurin series. So what is A value? 0. So please, where is my first derivative, please? My first derivative was here. Look at here. This is my first derivative at 0. What answer? 0. So first derivative is 0. Okay. What about my second derivative at 0? 2. Yes or no?
Yeah.
Second derivative at 0. Look at this one. Put here 0, please. 0. So answer how much? 2 is 2. Okay. What about my third derivative at 0? At 0, how much? -6. You are right. -6. And fourth derivative at 0? 24. Yes, good. So I got my second derivative I got is 2 third minus 6 fourth 24. Understand? Please make series now. Make the series now, please. It was which question number, please?
22.
22. Okay, now we are making Macdonald series because there is no A0. So the function was
X squared.
x squared
X plus 1.
x plus 1. Okay. F of A0, so it is 0. Very good, 0. Plus first derivative.
0.
So my first two terms are 0. Okay. So f of A0. First derivative is 0. Okay. Now
Plus
my second my second derivative is
2
2
times X
x
minus 0.
0. No need, please.
Yeah. X
No need for this. So x power 2
squared over 2 factorial.
over 2 factorial. Very nice. Plus my third derivative.
Negative
It is negative 6. X power 3 divided by 3 factorial plus my fourth derivative 24 x power 4 divided by 4 factorial, and then of course I have positive, negative, and negative, and it is continue. Please continue. Do you understand what I did?
Yes.
I just put the zeros in the Taylor's sorry, columns. See. Get the idea? Now please first simplify, then we check the pattern. These 0 terms you can remove it, no need. It doesn't affect 0, 0 finish, please. No need for that. Okay, now look at it.
It's 1.
2x squared, 2 factorial is 2 minus 6x cubed. 3 factorial is 6 plus 24 x power 4. 4 factorial is 24 minus and continue, please.
Sir, I just have a question.
Yeah, please.
And the last question we haven't simplified. We just wrote 1 factorial, 2 factorial, and when we wrote the sigma, it was over n factorial. But here we simplify.
Because my multiplier cancel, that's why. Look at here. That's why I simplify.
Okay.
Now this is x squared minus x cubed plus x4 and then continue. So do you have sign controller?
Yes.
Okay, yeah. So first of all, apply sigma. Sigma n is equal to 0 to infinity. Just check. Don't worry. First, we can start like that. When we cross check, then we see x power n, am I right? And yeah, sorry. First we add sign.
Negative 1 to the power of n.
-1 power n and x power n. Okay. Now look at here. Actually, my first term is how much? X squared. So definitely I cannot start from 0 because my first term is going to be what? 2. So I can start from how much? 2. Okay. Please cross check. As I put here 2 and I put 2 here. So -1 power 2 and x2. -1 power 2 is 1. My first term x squared. Please check correct.
Yes.
Okay, good.
Now,
Now,
why did you change it to 2? It was 0. Why did you change it to 2?
Because we started.
because if I start with 0,
It's X.
my first term becomes 1. I don't have 1. So you have to cross check your formula, please. Okay? That is working correct or not. That's why we realize it is not 0. It must start from 2. If I put 3, so -1 power 3, x power 3, -1 power 3 means negative, and next 3. My second term x3, oh yes, so it means it's working now correctly. So cross check, you can see that is working correct or not. Hope you understand how to get the patterns. Clear? Right. Can you go on one question? We have done it. Means we have nothing new now. So go home. Okay, right. So as I told you, one of the questions, one of the functions they give you to give the number of derivative means order 3, order 4, order, okay, 5, like that. And I told you we can give any function to differentiate, please, cosine, sine, ln x, ex, any function give you, okay? One question if you like that, maybe not tell the, number of derivatives, please, no order mention. So what you can do, take 3, 4 derivatives. And yeah, and then just check that in my question, what pattern I'm getting. Hope you understand, okay? That's all. This is what really about that, okay? Oh yes, have you finished survey of course?
Yes.
Survey, all of you? Please, if no kind go and somebody survey before is the last class, then you cannot, we not make you, so please do survey because they send me so many, emails that your school is very less, very less. So please, please go and do the survey. So this topic, understand, in 9.8, okay? 2 questions you will get, okay? I told you how you get the question.